Hey there, Patriots. So in this video, we are going to talk about probability of events using the word or and mutually exclusive events. So what is a probability that uses the word or? So if we're looking at or, the probability of one event having more than one favorable outcome, that means we're going to use the word or. So if more than one outcome would make me happy, we use the word or like this. So here's some examples. At a restaurant, the waitress asks you, what would you like to drink? And you respond, Coke or Pepsi, whichever one you have. So if she brings you a Coke, getting a Coke would be a favorable outcome. You'd be like, oh, okay, I got a Coke. That's favorable. Getting a Pepsi would also be considered a favorable outcome. You're only going to get one drink, but with that one drink, Coke or Pepsi both work. Well, another example, what if we're getting dressed for Spirit Week? And so we want to rock our red, white, or blue shirt. We don't know which one we want. So if I get any of the three, that is happy. So if I get a red would be considered a successful Spirit Week. A white shirt would be considered a successful Spirit Week. A blue shirt is considered a successful Spirit Week. All because we had the word or. Coke or Pepsi, red or white or blue. This or is understood before the white. All right, so a red is a success, a white is a success, a blue is a success. Well, how are we going to find that probability out? We are going to do that by using the addition rule of probability. If we are looking at the probability of two or more events that are linked with the word or, we are going to use this formula. Okay? So I am going to take the probability of A or B is going to be the probability of A. Everybody in this circle is A. Boom. Let's go ahead. Everybody in this circle is A. I am going to add that to B plus B. Right there. And then I'm going to subtract where A and B overlap. That's this space right here in the middle. You can already see it's green. So for A or B, you're going to take everybody in circle A, add it to everybody in circle B, and if they overlap, subtract the overlap. So one group plus the other group minus any overlap. Well, what if they don't have an overlap? Well, that's what we call mutually exclusive. Mutually exclusive events are events that do not occur at the same time. For example, when a coin is tossed, then the result will be heads or tails, but never both. I can't flip the coin once and get heads and tails. That's not happening. The probability of mutually exclusive events is always 0. Super important. They cannot happen with an and. And if you look at your Venn diagram, notice the circles never overlap. There is no and with mutually exclusive events. There is no and. The circle A and circle B do not overlap. So let's look at some. Let's look at our mutually exclusive events. A glass jar contains 1 red, 3 green, 2 blue, and 4 yellow marbles. Are the events of selecting a yellow and selecting a green marble mutually exclusive? Explain your answer. So what I want to know, can I reach my hand into the jar, pull out 1 marble, and that marble be both yellow and green at the same time? And that answer is a hard no. No, so selecting yellow and green marbles are mutually exclusive. It is impossible to get 1 marble that is both yellow and green. Mutually exclusive again. They are mutually exclusive. They are mutually exclusive because it's impossible to get one that is both outcomes. So what if we choose a single marble at random from the jar? We're just going to put our hand in the jar, pull out the marble. What is the probability that it is yellow and green? Well, remember, up here, we said they were mutually exclusive. And on the last page, we said if events are mutually exclusive, the probability of those two events with an and is always 0. It will not happen. A marble is impossible to be yellow and green. Probability of 0 means impossible for those outcomes to happen. Here's a deck of 52 cards. Are the events of selecting a queen and selecting a club mutually exclusive? So what I want to know is one card, both a queen and a club. So if you look at your card right here, this card right here is both a queen and a club. So that means my events are not mutually exclusive. No, a queen and a club are not mutually exclusive. There is one card that is both a queen and a club. So if we are not mutually exclusive, one card is both. One outcome, one card can give me both outcomes. So let's find the probability of this happening. So to find the probability that a card is a queen and a club, we're going to do the number of queen of clubs over the number of cards. By the way, this N right there, I almost said upside down U. That N, it means intersection. That is an and. So this is saying the probability of queen and club. You can write down the word and. I get a little lazy and I like my symbols. Probability of queen and club is the number of queen of clubs over the number of cards. So there is one queen of clubs. There are 52 cards. So the probability I get the queen of clubs randomly is 1 out of 52. Boom, that easy. Alrighty, Patriots, that brings us to the end of the video. If you have any questions, please ask your teacher. They will be glad to help you out. We'll see you in the next video, everybody.